Hi guys, I wanted to start out by giving you the answers to all the warm-up questions. So if you want to pause right now and just take a look, check your answers, or if you feel like you need to go through it step by step, again, please just pause the video. But I'm going to move on and start the notes. Okay, so all the problems we've done so far, we've been able to get a common base. But now we're going to get some questions where we can't get a common base. So how would we solve something like this? Well, we would have set it equal to x, and then we'd have 4 to the x equals 30. We can't get a common base, so if you remember something I briefly mentioned the other day in class, you would take the log of both sides, and when you have an exponent, it comes out in front. So you get x log 4 equals log 30. And what we've done is we've changed it to base 10 because that's what our calculator does. And when we solve for x, we just divide both sides by log base 10 of 4. And I don't need to write that base 10, so it's just log 4. So what do we have? X equals log 30 over log 4. That's the long way to do it. Just make sure you know that that is not the same thing as the log of 30 over 4. You have to, in your calculator, it typically puts a parenthesis here when you push it, plug in log. You got to end the parenthesis before you hit log of 4. So you'll notice up here, the shortened version of this change of base formula is you take the log of this number and then over the log of this number. And it says just base b in general because whatever b is, whatever base you're changing it to. All right, so log base 5, we could do the whole thing all over like we did over here, or we just know that to change the base, it would be log 7 over log 5, and then we'd plug that in our calculator, and we'd get about 1.209. And if it's on the calculator section of the test, you would go that far. If not, I might say leave it in calculator ready form. So this right here is calculator ready form. And this also here is calculator ready form. All right, let's go on to the next page. So I just want to quickly review natural logs. If you remember, natural log means log base e. And then if you change this to log base e of 1, you would set it equal to x to solve it. You'd have e to the x equals 1. So e to the x equals 1, well, that means x is 0. So that's the long way of showing you that the natural log of 1 is just 0. And then the natural log of e, again, if we do log base e of e, we would hopefully remember that those two would cancel each other out and give you 1. But if you needed to go the whole way and do the whole thing, e to the x equals e. E is the same as e to the first, so x equals 1. Or we can just remember that the natural log of e is equal to 1. And I'll write that here, equal to 1. So you can figure all these things out by doing it out like we've done all the other problems, or you could just commit them to memory. So let's look at the examples here. Remember that if you have, there's a lot here, right? So let's just start up here at the top. If you have an exponent, you can hopefully remember that you can bring it out in front. So that would be 8 natural log of e. This is just the exponent. And then remember the natural log of e equals 1. So what are we down to? We have log base 4 of 4 to the 8th. And then if you remember, log base 4 of 4 cancels, so your answer is just 8. And we're going to review this rule here, where I said that you can take this exponent and put it in front. That's a rule down here that we're going to go over in just a minute. But I want to stick to natural logs real quick. In this case, you've kind of got the same thing going on here. So we're just going to go the other way in this one. And why am I going to go the other way? Because that's going to give me 1/2 e natural log 2 cubed. And I went that way because now these things are going to cancel, right? And I'm going to be left with 1/2 times 2 cubed, which is 1/2 times 8, which is 4. And that's the answer there. The next one, there are a few ways to do it, but this is the same thing as the natural log of e to the negative 1. And using our rule that says you can put the exponent out in front, that's negative 1 natural log of e. And we know that the natural log of e is equal to 1. So we end up with negative 1 times 1, which is just negative 1. So I just wanted to throw in some natural logs there so you know what those are. Now, let's review those rules I kept mentioning up top there. If you remember from previous math classes, if you have two things being multiplied, you can separate it into two logs, log base b of m plus log base b of n. And sometimes that just makes it easier to help solve. And then when you have division, you can change it and make it log base b of m minus log base b of n. And then when you have an exponent, you can put it in front, k log base b of m. Okay, so we're going to use that to do some problems down here, but first just keep in mind that the log of u plus w is not the log of u plus the log of w, and the same thing goes for subtraction. Only if these two in here were being multiplied can you separate it and make it addition. You don't distribute the word log here, so just kind of keep that in mind. Now let's look at the first one. In this first one, I don't really want to have to multiply out 9 times 27 because this is on the non-calculator section. So the best way to do this is it's being multiplied, so you can separate it into addition. Log base 3 of 9 plus log base 3 of 27. You might be able to look at this and know what the log base 3 of 9 is. If not, you just do it like we've learned. Log base 3 of 9, you'd set it equal to x. Then 3 to the x equals 9. So obviously x equals 2. Here, if you need to set it equal to x, 3 to the x equals 27. And then you know that x is 3. So what do we have? 2 plus 3 equals 5. So you just do that to make the math a little bit easier. Now this next one, there's a couple ways we could do it. For the sake of learning this property here, let's go ahead and use the fact that we can change this to subtraction. Log base 3 of 9 minus log base 3 of 27. So we just found out over here that the log base 3 of 9 was 2. So we can put in 2 minus, and then we also found over here that the log base 3 of 27 is 3. So just minus 3 equals negative 1. So there you have it. Now let's go ahead and do it the other way. So now I have addition and I want to make it multiplication because I don't know log base 10 of 5 and I don't know log base 10 of 4. But before I can make this multiplication, I have this coefficient in front which I need to make the power. So I've got log base 10 of 5 squared plus log base 10 of 4, which is obviously log base 10 of 25 plus log base 10 of 4. Now when I multiply them, log base 10 of 25 times 4, I've got log base 10 of 100, which we know, we could probably look at it and tell, but if you can't, then you just set it equal to x. 10 to the x equals 100. 10 to the x equals 100. And I think you can see that x equals 2. And we can use our properties up here as well. If you have subtraction, that means division. So that's the same as log base 4 of 40 over 5. So that's log base 4 of 8. When we do our little around the world, we have 4 to the x equals 8. And I need to erase this to make room. So hopefully you got everything. And this would be 2 squared to the x equals 2 cubed. So 2x equals 3, and x equals 3 over 2. So we just use those rules to help us simplify. Now I'm going to do the same thing, except I'm going to condense it, except that I'm going to have all letters in here. But you follow the same rules. The same rules apply, and that is that you need to make your coefficients exponents. So all of these things are coefficients. How do I know that that 4 is a coefficient and doesn't belong with the s plus 4? Well, I would have put it in parentheses if it was supposed to go with that and be s plus 4. But I didn't, so I know I move it up to the exponent. So what do I have right now, just moving those? Log base b of r to the 1/2 plus log base b of s to the 1/2 plus log base b of t to the 4th. And it's all addition, so that's all multiplication. So that's log base b of r to the 1/2 times s to the 1/2 times t to the 4th. As good mathematicians that we are, the nice way to write this is log base b of t to the 4th times the square root of rs, because remember the square to the 1/2 means square root. So, and we usually don't want to put anything that's not under the square root on the opposite side of it. Like we don't want to put the t here because then you could get confused about if it's underneath or not. Now, would it be okay if you left it like this? Yes, unless I said no fractional exponents, then you'd at least need to go and make it square root. But does this order matter? No. So here's the answer to that one. I'm going to do the same thing on the next one. It says expressed as a single logarithm. So I'm going to take this 5 and make it an exponent. I'm going to take this 7 and make it an exponent. And I'm going to take this 4 and make it an exponent. So I've got log base 4 of 2 to the 5th plus log base 4 of x to the 7th plus log base 4 of y to the 4th. And again, I did all multiplication. Not sure why I did that. There's no division practice, but we got this. So this is log base 4, 2 to the 5th is 32, times x to the 7th times y to the 4th. And that's all it is when I ask you to condense it into one log. I could also ask you to separate something like this, expand the logarithm. So the first thing I want to, I guess I should say, undo is this division here. So I'm going to change this to log base 7 of 3x squared minus log base 7 of 5y cubed. And then this is a step students often forget. This is 3 times x squared, so it needs separated. You can't just put this 2 out in front because, first of all, the 2 doesn't apply to the 3, but also this is multiplication. So we're going to separate that multiplication and make it log base 7 of 3 plus log base 7 of x squared minus, I'm going to do the same thing here and separate, log base 7 of 5 plus log base 7 of y cubed. And then the only thing left to do is get these exponents out in front where they belong. And so my final answer is going to be log base 7 of 3 plus 2 log base 7 of x minus log base 7 of 5. And notice I distribute the subtraction. So then minus, 3 log base 7 of y. And that's the final answer if I'm asked to expand. Now the next part of the lesson I'm going to keep separate because my period C class got through this during class.